Okay, so these are the applications of frequency modulation listed here. And here is the comparison between AM and FM. So according to the definition, what is given here, the amplitude of carrier is varied in accordance with the amplitude of the modulated signal, keeping frequency and phase constant, but that is the opposite in case of FM. Frequency of the carrier is varied, okay, but the amplitude and phase will be the constant. So the constant parameters are here. These are the modulated signal after the combinations of the carrier signal and the modulating signal for AM, and this is for FM. Modulation index that can be defined by using EM by EC in case of AM wave, and that is delta by FM in case of FM wave. Number of sidebands only 2, but here the number of sidebands are infinite and depends on the modulation index M. Bandwidth is given as 2 FM in case of amplitude modulation, but in case of FM that will be depend on the deviation and the maximum frequency, which will be added together and that will be multiplied by 2. Applications are there, AM application and FM application. So this is the difference between the AM and FM wave. Next to the phase modulation, where it is a type of modulation where the phase of the carrier signal it will be varied according to the amplitude variations of as per the amplitude variations of the message signals. Okay, so in phase modulation, the phase of the carrier signal is varied, whereas the amplitude of the carrier signal remains constant. Okay, and that's why it is called the phase modulation technique. And here the first figure shows the message signal, just in case of the same in case of AM and FM, both this is the message signal, and the second figure shows the carrier signal, and that is the modulated signal, okay, which is in phase modulation. So it is phase modulated signal, and here the phase, actually you can see it from these figures, the phase of both the positive and negative half cycle, okay, of the carrier signal varies as per amplitude variations of the modulating signal. Now during the positive half cycle, the carrier signal phase shifts in one direction, whereas during the negative half cycle, the carrier signal phase shifts in the opposite direction. Okay, so in phase modulation, the phase deviation is directly proportional to the amplitude of the message signal. Okay, then actually here in phase modulation, the noise immunity is better than the amplitude modulation if it is compared with the amplitude modulation. The noise immunity of the phase modulation is not as good as frequency, but it is better than the amplitude modulation, and the signal to noise ratio of the phase modulation is better than the amplitude modulation. Okay, and same, the modulation index of this phase modulation is directly proportional to the message signal, and it is this modulation technique, phase modulation technique, used for some mobile radio services. Okay, so actually phase modulation and the frequency modulations are closely related to each other. In both phase and frequency modulation, the total phase angle of the modulated signal actually varies. In practice, the phase modulation and frequency modulations are dependent on each other. When the phase of the carrier signal varies, the frequency of the carrier signal also varies. Similarly, when the frequency of the carrier signal varies, the phase of the carrier signal also varies. However, the phase modulation and frequency modulations are not directly proportional to each other. In frequency modulation, what happened, the total phase angle of a carrier wave changes for a short period due to the change in frequency of the carrier wave. In phase modulation, the frequency of a carrier wave changes for a very short or negligible period due to the change in phase of a carrier wave. Okay, that's why these are closely related. Okay, so that's all for today. If you have any queries, any doubt, you can ask me. Unmute yourself, and do you have any doubt? Okay, so if you don't have any queries, so give the attendance. Switch on your videos one by one. Roll number 6. Roll number 6. Roll 7. Roll number 7, Tirtho. Roll number 8.
Yes, sir.
Roll 9. Roll number 9. Swapnodeep. Swapnodeep. Roll 9. Okay, 10. Shubhijita. Roll number 10. Shubhijita. Roll number 11. Shubhankar. 11.
Yes, sir.
Shubhankar.
Yes, sir.
12. Roll number 12. Shubham. Roll number 12.
Yes, sir.
Roll number 13. Shubham Gorai. 13.
Sir, 12, yes, sir.
Yes, mark. 13. 14. Roll number 14. 15.
Yes, sir. Roll 15, sir.
Yes. Okay. 16. Roll number 16. Next. Roll number 16. 16. Shinantu. Roll number 17.
Yes, sir.
Okay. Next.
Yes,
roll
sir.
number, yes. Roll number 18. Roll number 18. Somo Mojumdar. Somo. Roll number 19. Siddhartha.
Yes, sir. Present, sir.
20. Roll 20. Roll 20. 21. 22. Shaunak Bose. 23. Shandeep Garai. 25. Satyapriyo. 26. Satyam Anand. 27. Roshan Kumar. 27. 28. 29. Ritankar. 30. Roll number 30. Ritom.
Yes, sir. 30.
32. Rishabh. 32. 33. Rahul Ranjan. 33. Rahul. 35. Pooja.
Yes, sir.
36. Pratiti. 36. Pratiti. 37. Roll number 37. 38. 39.
Yes, sir.
39. Sorry. 38.
Yes, sir. 39.
39 Putikrit. Achha.
39, sir. Present.
39. Okay. 40. Next 40. Pallavi. 41. 42.
Yes, sir.
Nishant.
42 present, sir.
43.
Yes, sir.
44.
Present, sir.
Okay. 45. Mithilesh. 45. 46. Mohammad Irshad. 47. Kaustubh Trivedi. 48. Karandeep. 49. Jyotirmoy. 50. Himanshu.
Sir.
51. Ishani. 52.
Yes, sir.
53. 53. Devjit. 54. Devanka.
Present, sir.
50
Present, sir.
Yes. 55.
Yes, sir.
56.
Present, sir.
57.
Present, sir.
58. Orko Mitra. Orko. 59.
Present, sir.
60.
Present, sir.
61. Ankit Kumar. Ankit Kumar. 62. Aniket Maiti.
Sir.
Yes. 63. Yes.
Present, sir.
63. Avinash.
Yes, sir.
Okay. 64.
Present, sir.
65.
Sir,
65.
64 present.
Yes. 65. 66. 66. 67. 68. Roll number 68. Roll number 1. Lateral. Tanushree. Lateral 1. Lateral 2. Robin.
Yes, sir. Yes, sir.
And 3. Moinak. Okay. Marked. Okay. Done. Is there anyone?
Sir, roll 42, sir.
Roll 42 is given.
Okay.
Anyone else? Okay. So thank you all. Thank you very much. See you on next week.
Thank you, sir.
Thank you, sir.